This section will instruct the builder to fabricate scissors, install the tail boom idler pulleys and belts, remount the tail boom, and install the control cable. Note, it may be easier to mount the idler pulleys and scissors while the tail boom is off the airframe. Locate the following components. Reference construction prints E09-2000 tail boom assembly, E17-2000 tail rotor, E17-2001 tail rotor details. Clean a small area of the tail rotor idler pulley with acetone and a clean cloth. Then apply the temperature strip near the edge of the pulley. Apply a temperature strip to the other idler pulley and to the drive pulley that is mounted to the tail rotor shaft. These strips are to be checked at every pre- and post-flight inspection to help monitor the condition of the tail rotor belts. Refer to the rigging section and flight manual for further details. Using template E18-1, cut out the idler pulley mounting scissors. Bolt two of the idler pulley mounting scissors together with the idler arm spool between them. Install the spacers into each pulley bearing, then bolt the pulley assembly into the mounting scissors. Tighten both bolts. Check to ensure the assembly will fit into the machined area of the bulkheads without binding or being too loose. File the spool or add shims to obtain the correct fit. Apply grease to the outside of the scissors, inside of the bulkhead lugs, and both bolts. Install the pulley assemblies into the second and third bulkheads. Tighten bolts snug, then loosen them just enough to allow the scissors to pivot freely in the bulkheads. It is important to make sure there is clearance around the ears of the scissors and inside radius of the bulkhead to allow the assembly to pivot freely throughout its full range of travel. This shows the idler pulley mounted into position on the third bulkhead. Be sure to mount the idler pulley assemblies with the pulley's bearing temperature strip visible from the tunnel inspection openings. This is the tail rotor cable and the tail rotor cable mount tube weldment as received from Rotorway. Install the tail rotor cable into the mount tube weldment. Install the mount tube weldment and cable end to the tail rotor assembly on the floor as shown here. Drill on assembly the 3/16" hole for the bolt that holds the mount tube to the bearing plate on the passenger side. Do not install the bolt at this time. Install the tail rotor control cable with the mount tube weldment into the tail boom. Route it along the bottom until it reaches the third bulkhead, then route it to the passenger side until it reaches the tail rotor assembly. Tie the cable to the horizontal trim fin spar to keep it away from the belts, pulleys, and the bottom of the tail boom. Reference the construction print E09-2000 for the proper belt placement and install the belts. From the secondary to the bottom of the first idler pulley, the first idler pulley to the bottom of the second idler pulley, and the top of the second idler pulley to the tail rotor shaft pulley. Note, the 112-inch belt is the rear tail rotor drive belt. Final install the tail rotor shaft assembly. Make sure the two bolts that hold the pitch actuator arm pivot casting to the bearing plate are safety wired. Loctite the bearings to the tail rotor shaft. Install the 112-inch belt on the assembly before installing the tail rotor assembly into the tail boom. Set the lock rings and tighten the set screws. You will need to remove the idler pulleys from the scissors to install the drive belts. The horizontal trim fin spar must be removed on one side to allow the second belt to route properly. Install the bolt that secures the mount tube weldment to the pivot casting. Install the bolt that secures the rod end to the pitch actuator arms. Final install the cross shaft for the foot pedals. Grease the shaft bushings and the scissor beams. Blue Loctite the bolts that hold the bushings to the airframe. Drill and rivet the aluminum bushings to the airframe as shown. Drill a 1/16 inch hole and safety wire the bolt to the airframe. Refer to Section 25 for belt tensioning procedures and rigging the directional control. This section will instruct the builder to install the fan drive countershaft, water pump, and the alternator and voltage regulator. Locate the following components. Reference construction print E31-2000 fan drive countershaft, water pump, and alternator. Referring to the construction print, assemble the fan drive countershaft as shown. Place the pulleys and bearings on the shaft. The lower and larger pulleys should be even with the end of the shaft. The bottom pulley should have the hub up, and the top pulley should have the hub down. Measure the distance between the pulleys on the secondary and match that distance in the fan drive countershaft. Using a letter D drill bit, drill the holes for the bolts that hold the pulleys to the shaft. Then install the bolts. This must be a tight fit. If the shaft extends past the top pulley, it may be necessary to cut it if it contacts the airframe bracket. Mount the assembly on the airframe brackets and install the belts. Move the assembly up or down in the bearings for alignment. The lower bearing flanges may be placed above or below the airframe bracket as required. The aluminum spacers may be trimmed or may not be needed at all. On final assembly, Loctite both pulleys and bearings to the shaft. Set the lock rings with a hammer and punch. Tighten the set screws on both lock rings. This is the assembled fan drive installed in the airframe brackets. Refer to construction print E31-2000 when constructing the water pump assembly. Lay out and drill the 5/16 of an inch holes in the backing plate. Cut off the corner if necessary to clear the airframe tube when the water pump is at the end of its travel as shown. Bolt the water pump on the airframe and position the pulley on the shaft for the correct belt alignment. This is a tight fit. Do not drive the pulley in the shaft with a hammer, as this will damage the seal. With the square drive tubes level fore aft and laterally, use a protractor to obtain the correct position for the water pump pulley as shown. Remove the water pump and drill the 3/16 of an inch hole through the pulley and shaft. Reinstall the pump and backing plate on the airframe. The alternator and voltage regulator as received from Rotorway. Mask the openings in the alternator to prevent metal chips from entering, then cut off the excess material on the scribe line. Connect the wires from the voltage regulator to the alternator according to print E35-2001. Mount the voltage regulator to the alternator using the self-tapping screws and lock washers provided. Note, these screws will cut their own threads as they are driven in. Make sure the screws thread straight into the holes. Cut the existing connector off of the yellow wire. Install a 1-pin connector and insulator supplied on E35 card 1F. Use a pair of crimpers to secure the connector to the wire end and then install the insulator. Mount the alternator on the airframe bracket. Place a straight edge across the pulleys to check alignment. Add washers between the bracket and alternator if necessary to achieve alignment. Install the bolt from the bottom. Fabricate the belt adjusting strap. Drill the body of the water pump in this approximate area shown and bolt the strap to the water pump and alternator. Install and tension the belt. It should be tight enough so that the alternator pulley is just able to turn by hand. Safety wire the bolt to the bracket. The water pump, alternator, and belt adjusting strap installed in the airframe. This section will instruct the builder to install the chain oil bath. Locate the following components. Reference construction print E33-2000 chain oil bath. It will be necessary to remove the chain and lift the main shaft and sprocket to install the oil bath. These are the fiberglass parts of the oil bath. Use a medium grit sandpaper to sand the entire edge of the lower pan the same width as the rubber stripping both inside and out. Wipe the area clean with acetone before gluing the rubber in place to achieve proper bonding. Open up the rubber stripping and wipe it clean with acetone. All of the white powder must be removed completely. Use sandpaper to scuff up the rubber to help it bond to the lower oil bath pan. When installing the rubber gasket material to the bottom oil bath pan, the thin flat part of the rubber must be positioned inside. Fit the rubber stripping and cut it to length. Note, cut a few notches on the inside of the rubber at the small end of the oil bath to help it fit tightly around the curve. Mix the 3M 2-part epoxy adhesive and apply a layer to both pieces. Hold the rubber in place with tape or clamps as necessary to keep the seal tight while the epoxy is drying. A good idea is to place the lower oil bath pan upside down on a flat surface so that the epoxy remains inside the rubber stripping. Open the hole in the lower oil bath pan to accept the rear oil seal as per the construction print. Only the aluminum mounting ring on the oil seal should touch the fiberglass pan. The seal will be glued on the inside of the oil bath. Open the hole in the lower oil bath where the main shaft passes through. Note, no seal is required where the main rotor shaft passes through the oil bath. The oil level is not high enough at that point to spill out. Position the lower oil bath pan on the airframe so that it is centered over the secondary shaft and the lower main shaft bearing flange. Use a piece of string to help locate the position of the square tube from above. As per the revision in the construction print, the forward bolt for the oil bath should now be located in this position. Drill 3/16" holes to secure the lower oil bath to the fore and aft square drive mount tube on the airframe. Use a large fender washer between each of the 3/16" bolts and the fiberglass surface. The oil bath cannot touch any moving, rotating parts. When mounting the oil bath, make sure there is a gap between the main drive sprocket and the bottom of the oil bath. This can be checked by pushing upward on the bottom of the oil bath and observing the amount of movement before the fiberglass touches the sprocket. Cut an opening for the master link insertion plate in the lower oil bath pan shown here. The fore-aft position must be located within this area because you must be able to remove the screws through the plexiglass inspection window opening. Use E33-1 to cut out the insertion plate and install the nut plates per the construction print. Final install the oil bath assembly. The secondary bearing housing and lower bearing must be final installed. Make sure that there are no sharp edges on the secondary shaft so that the seal is not damaged when placing it on the shaft. If necessary, sand a light radius on any sharp edges of the shaft using 400 grit sandpaper. Then clean the shaft with acetone. Clean the square tubes with acetone. Apply a bead of silicone to the square drive tubes as shown. Apply a generous amount of silicone sealant to prevent oil leakage through the bolt holes. Note, once the oil seal has been glued in place, the position of the secondary shaft or the lower pan itself cannot be changed or the seal will leak. Use sandpaper to roughen the surface of the aluminum ring around the oil seal to help ensure a good bond. Also sand the mating surface of the oil bath. This area must be flat. Clean the sanded area with acetone. Apply a layer of 3M 2-part epoxy adhesive to both surfaces to be bonded. Carefully install the seal over the shaft and press in position. Use no weight to hold seal down, simply push in place and let seal center itself. Apply a light coat of oil to the rubber seal, being careful not to contaminate the bonding surface. Wipe off excess epoxy, leaving a little around the edge to ensure a complete seal. Do not rotate the secondary shaft until the epoxy is hardened, approximately 12 hours. After this period of time, apply additional amount of oil to the seal before rotating the secondary shaft. If these procedures are followed carefully, the rear oil seal should not leak. Final install the main shaft, hub, and sprocket. Make sure the bolt heads that hold the main sprocket to the hub have been safety wired to the sprocket as shown. Reinstall the lock ring and main sprocket to the main shaft. Make sure the sprocket mark matches the mark on the shaft end for proper alignment. Install the bolts. Loctite the lower shaft bearing to the main shaft. Turn the lock rings in the same direction as the main shaft will turn. Do not set the lock rings until the Loctite is dry. Refer to Section 11 on procedures to set lock rings on the main shaft. On final assembly, Loctite the lower main shaft bearing to the shaft, set the lock ring and tighten the set screw. Note, this procedure is to be done after the lower oil bath has been installed. In this application, the bearing lock ring must be set in the direction of rotation. The main shaft turns clockwise, viewed from above. This is done by using a drift punch sized for the hole in the lock ring and a hammer approximately 10 to 14 ounces in weight. Strike the punch in the direction the bearing is turning. No more than 2 or 3 strikes are necessary to set the ring into position. Then tighten the set screw firmly. If the application requires Loctite, wait until the Loctite is dry before setting the lock ring. Keep in mind, the larger the bearing and lock ring, the more force it will take to set. Torque the sprocket bolts to 18 foot-pounds and safety wire the sprockets as per the construction prints. It shows the sprocket to hub bolt shanks are safety wired to each other. The hub to main shaft bolt shanks are safety wired to each other. The hub to main shaft bolt heads are safety wired to each other. Install the secondary sprocket. Torque the 3 5/16" bolts to 10 to 12 foot-pounds and safety wire the 3 bolts as per the construction print. Reinstall the chain and the master link. Install the master link through the cutout in the lower pan. Install the clip that locks the master link into position. Remember, the master link clip's opening must be in the trailing position. Sand the bottom of the pan and the insertion plate before applying silicone. Seal the insertion cover to the bottom of the oil bath with silicone and tighten the 4 screws. Cut out the inspection window to fit on the rear oil bath cover as shown. The window should not extend forward past the wooden brace on the underside of the cover. The sides of the window should be far enough away from the edge to prevent the nut plates from contacting the rubber stripping around the edge of the pan. Cut out an opening in the rear cover 3/4 of an inch smaller on all sides of the inspection window. Do not cut through the wooden brace on the underside of the cover. Using sandpaper, sand an area 3/4 of an inch wide all around the opening, and also sand the matching area of the window. This will roughen the surface for a better seal. Lay out and drill the screw holes in the window. Place the window on the rear cover and drill the holes through the cover. Install the nut plates on the rear cover, then install the window using silicone on the sanded area. Do not silicone the inspection window in place at this time. You will use this opening to add the mix of 1 quart of oil and 1 can of STP oil treatment for the chain and sprockets lubricant. Place the 2 top cover pieces over the lower pan. Trim the overlapping part of the front cover if necessary to achieve a snug fit. Locate the nut plates according to the dimensions on the construction print, making sure that the nut plates do not interfere with the chain. Reference the construction print for the location of the spring grommets. Install the 5/32 inch rivets. These rivets are used as spring grommets. Push out the shank of each rivet so the ends of the springs will fit through. Before installing the top covers, check the following. 1. Chain tension. 2. Correctly installed master link and insertion plate. 3. Safety wire on secondary retainer plate bolts and main sprocket hub to main rotor shaft bolts. 4. Safety wire on main sprocket to sprocket hub bolts. Reinstall the safety spacer. Remember to coat the main shaft with grease. On final install, blow out the lower oil bath pan to clear it of any dust or debris. Clean the front and rear oil bath covers and rubber stripping on the lower oil bath pan with acetone. Lay a bead of silicone approximately the size of a pencil on the inside corners of the covers. Apply a small amount of silicone over the seam where the two halves of the cover join to prevent splash leakage. Then install the screws and springs. This is the spring installed with the rubber strip. Using template E33-2, fabricate the rain guard and install it with the hose clamp provided. Drill a hole in the middle and use a bandsaw to cut the opening for the shaft. Note: be sure that the rain guard does not rub on the top of the oil bath when the shaft is turning. This is the finished chain oil bath installed in place on the airframe. Because of the size of the oil bath, the oil level is not high enough to spill out. If the oil bath leaks, it is probably due to one of the following. A. Not enough sealant around the front and rear covers. B. The rear oil seal was installed before the oil bath was bolted solid to the airframe, or the oil bath or secondary assembly was moved after the seal was installed. C. Moving parts are rubbing against the fiberglass pan and have worn through. Before starting the engine, make sure oil has been added to the oil bath. The correct amount is 1 quart of engine oil and 1 can of STP oil treatment. Mix the two oils together before pouring them into the chain oil bath. This section will instruct the builder to install the collective scissor, the collective spring attachment, and the cyclic control cables to the rotor hub assembly. Locate the following components. Reference construction prints E23-2000 collective spring and scissor, E49-2001 elastomeric main shaft, E49-2002 elastomeric swash plate. Construct the collective scissors mount as shown on print E23-2000. When bolting it to the hood bracket, be sure that the fore and aft ears of the non-rotating swash plate are parallel with the aircraft's centerline. When drilling the airframe, cover the oil bath and engine with a cloth to catch the metal shavings. These are the parts to the collective control rod. Install one collective control rod end plug in one end of the control rod with a supplied bolt. Do not install the other end plug yet, as the control rod may need to be trimmed. Control arm G should be approximately 35 degrees from the center line of the collective and located approximately 7 1/4 inches from the center of the pilot stick as shown. When the collective is at the center of travel, control arm G and the collective control rod should be 90 degrees relative to each other. Hold this position, drill control G, and install the bolt. When the collective is in the full down position, the bottom of the slider ball should be approximately 50 thousandths from the top of the main shaft bearing. Adjust the slider ball clamp to achieve this measurement. The clamp is the down stop for the slider ball. When the collective is in the full up position, the lower part of the slider ball must not come out of the slider ball clamp. Fabricate the collective control spring attachment bracket from E25-3100 material and drill the 2 holes as per construction print E23-2000. Note the collective spring length is as follows. When the collective is in the full up position, the spring length should be 7 1/2 inches. When the collective is in its full down position, the spring length should be 8 3/4 inches. Drill the airframe hood bracket and install the eye bolt for the collective spring. Use an all-metal thin lock nut on the eye bolt. Finally, install the collective control shaft to the airframe. Grease the bushings, use blue Loctite on the bolt threads, rivet the aluminum bushing to the airframe, and safety wire the bolt to the airframe. Install the cyclic control cables in the cyclic cable mount, so there is an equal amount of thread on both the inside and outside of the cable mount. Install the cyclic control cable T on the end of the cyclic control cables so that the rod end is offset to one side of the opening in the non-rotating swash plate. For the correct bias of the cyclic control cables, use a spring scale and attach it to the rod end. Pull 4 pounds in the direction shown to line the rod end with the opening in the non-rotating swash plate. Adjust the 1/4 inch nuts on the ends of the cables until this is achieved. When the bias is correct, install the rod end in the non-rotating swash plate with the supplied bolts. final, install the cyclic control shaft to the airframe. Grease the bushings, use blue Loctite on the bolt threads, rivet the aluminum bushing to the airframe, and safety wire the bolt to the airframe.